All right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for our textbook, Microsoft Visual C# 2017, An Introduction to Object-Oriented Programming by Joyce Farrell for the Rankin Technical College AWD Application and Web Development 1100 Programming Fundamentals with C# class for the spring 2018 semester. I'm up to Chapter 4 of 14, Making Decisions. And I'm going to, as I have been doing, I'm going to bounce back and forth between the program that I wrote in the last chapter, which was a very simple calculator, which just adds two numbers, and these slides. So our objectives here: understand logic planning tools and decision making, making decisions using if statements, making decisions using if-else statements, using compound expressions in if statements, making decisions using switch statements, use the conditional operator, use the not operator, avoid common errors that are associated with making decisions, and appreciate decision-making issues in GUI programs. So, they talk here first about pseudocode, flowcharts, sequence structure, etc. A couple things. First of all, pseudocode. Pseudo means false. So pseudocode is not computer code, but it's English that ideally uses keywords, the types of words that are used in programming languages, so that it's easier. You know, if somebody says to you, I've got this pseudocode, what language do you want me to write the program in? And if they say, what language do you know, and you give them 5 languages, they should be able to say, that's fine, just pick one. So pseudocode is language agnostic. It doesn't matter. Flowcharts, show you this very quickly. This is dating myself here, so this is back in the 80s. We used to use a flowchart template. In fact, I don't want to do it there. Let's go back here and go to Google Images and put in flowchart template. This is the kind of thing, do they have one? There. I had to use this back when I was your age. All right, we had to draw on paper what we wanted the program to do. These symbols all meant something. This was a process. This was an input-output. That was a terminator. This was a decision statement. That's kind of what we're talking about in this chapter. All right? Not used that much anymore, but you know, people who are purists still do. The programs we've done so far have been sequential in nature, where one step has followed the other. It's not really, when you think about it, it's not exactly how life works. All right? Sometimes, as it says, logical steps do not follow in an unconditional sequence. An even better example than this is you're going down a road, and the road ends. And you've got your choice. You can either go off to the left or go off to the right. All right? And let's just say the road is one way, so you can't back up. So you've got to go in one direction or another. That means if you want to go, for example, let's say if I want to go, I don't know, if I want to go north, I turn left. Else, if I want to go south, I turn right, type of an idea. All right? That's a decision structure, where you choose between alternative courses of action. All computer decisions, as mentioned here, are based on true-false decisions in their most basic format. So, there you go. There's an example that's very similar to the one I just showed you. To do this, there's different ways you can do it. The first one we're going to learn about is a simple if statement. All right? So what we'll do is we'll ask the user, for lack of better words, a question, and then based on their answer, we'll do something or we won't do something. How's that? Now, the if statement, if we want to put in multiple statements, we put it in a block, which means we put curly braces around it. I would recommend, even if it's just one statement, always use curly braces. It's just a good habit to get into. Now, I'm going to try something here, and it's going to look a little strange, but please bear with me. I could pause this, but I'm not going to. All right, I'm going to actually come in, and you may or may not have noticed this, but when we run this exit routine, the program ends. I mean, that's what it's supposed to do. The button says exit, boom, it's done. What if we don't want that to happen? Well, I'm going to put in this code here. Now, I'll explain it to you, I promise, but hold on just a second. Let's run this first. Now when I click exit, look what happens. It comes up with a message. It says, do you want to exit the program now? If I click no, I stay in the program. If I click yes, I end the program. So this is our first foray, or our first example of going in and looking at an if statement. If we put in yes, do this. There's no else. So if we do this or we don't do it, that's it. Now where it says here, exit the program now, that was the message that came up. We had one button that said yes and one that said no. We had a title at the top that said exit program. We had a little icon over there with an I on it, which meant it was information. So in English, this is saying, hey, you've got a message box that just came up that says on it, exit the program now. And if you click yes, exit. And if you click no, which is the other option, don't do anything. All right, so I just very quickly gave you, that's pretty much the logic that you would use for a regular if statement. Now, they're doing this with flowcharts. You can look at that at your leisure. All right? You can have an if within an if. So imagine this. This is the example I typically use, and it's not a terrific example, but it works. All right? So imagine that I decide that I'm moving into a new house, and I'm going to have a party. And I've decided that if you want to go to the party, two things must happen. Number one, you must be 21 years of age or older. All right, because we'll have alcohol at the party, let's say. And number two, even though I don't drink, all right, you must be a Rankin AWD, Application and Web Development, student. So both of those must be true. So I can say if age greater than or equal to 21 and let's say status equal AWD. All right, and don't worry so much about the way that this code is set up, but the point is this. I've got an at sign followed by an at sign there, which means and, which means both of these must be true. So you can imagine if I came over here and I said, and, so you must be 21 years of age or older, and you must be a Rankin ID student. So both of them must be true. In fact, the way that C# works, and this is the way many programming languages work, it uses what's called short circuiting. So if what I put here, if this is true, if this is false, so let's say somebody wants to come but they're 19. They don't meet this criteria, so we don't even check that one. All right, so now it's getting pretty close to party time, and I've got all this food and all this drinks and whatever, and there's 3 people coming. All right, so I changed this from an and to an or. All right. So it looks like that. Now, if either one of these criteria are true, or if they're both true, so if any Rankin student can now come to the party, anybody who's over 21 can now come to the party. So when we used 2 at signs, both conditions had to be true, or the whole thing was false. All right? When we used an or like we have here, both conditions, if they're both false, you can't do it, otherwise it's true. And if that confuses you, look at it like this, because I'm going to create for you what are called truth tables for an and for an or, and for what's called a not. Just let me write this. All right, and let's say we've got 2 different things. We've got X and we've got Y. All right, if X is true, and y is true, then the whole thing is true. If x is false and y is true, then the whole thing is false. If x is true but y is false, then the whole thing is false. And if they're both false, then the whole thing is false. So this would be, right here, this would represent a condition like this. This would represent a condition like this. And when we use and, if both sides are true, the whole thing's true. Otherwise, it's false. All right, now let's contrast that with an or, which is two pipe signs, which is hold down on the shift key and right above your enter key. Here, we're going to put in true, 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 false, true, 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 false, true, false, false, false. Notice the difference. Here it's always true unless everything's false. Here it's always false unless everything's true. They're kind of opposites of one another. And not is known as an inverter. So, not true is false. All right, not false is true. Okay? That's pretty much computer logic in a nutshell right there. So with a nested if, I didn't show you that yet. What if I decided that instead of writing it the way that I just showed you, like this, I wanted to instead write it like this. So let me leave this up here, and now I'm going to write if age is greater than or equal to 21, and I'm going to put a curly brace here, but now I'm going to say if status equal, oops, AWD, do something. I don't care what it is. You can come to the party. All right, notice the difference. Rather than having one if statement, I now have two. The only way that I check this is if this one's true. So I've gone in, this would actually be more an and here, but I've gone in and I've taken here, I've written a complex condition as one statement, and here I've broken it up into two statements. So that's nesting right there, what's in blue. All right. Again, this won't totally make a lot of sense until you're out there doing it. All right. So they've got another program here where they tell you to enter two numbers, and they tell you, you know, whatever. Okay. I'm going to try something different. I'm going to go back to our program here. Okay, and I'm going to grab this thing here with this message box. And I'm going to say here, let's see. Because we're talking about making decisions with an if. All right, I want to be able to show you a couple things here with that. So what I'm going to show you is kind of silly, but we'll use it anyway. Let's see. Let's assume, for whatever reason, that rather than doing this, okay, we're going to say here, if we only want to add, for whatever reason, we only want to add even numbers together. So we're going to say here, if num1 mod 2 equal 0. Now, do you know what that means? No. That means if the number is evenly divisible by 2. All right, if num2 mod 2 equal 0. All right. Like I said, this is a silly convoluted example. All right, so if that's the case, then I'm going to do this. I'm going to have to change this around just a little bit. So I'm going to say here int answer equals 0. Okay. So I'm going to say here, we're going to put it in here, else number 2 is odd, I only add even numbers. Right, and I'm going to grab this, and I'm going to put it down here, and I'm going to say number 1 is odd. All right, so it's much easier to show you this with a run than anything. All right, so I'm running the program, and I'm going to put in here 22 and 44. And you'll notice 22 plus 44 equals 66. Good, I can clear. Now I'm going to put in here 33 and 22. And notice what it says now. Number 1 is odd. I only add even numbers. All right, so I clear it. Now I put a 44 in here, but I put a 33 in here. And it says number 2 is odd. I only add even numbers. So this will now only add if both the numbers that are in here are even. All right? What I get from nesting like this is I can tell which number that I put in was odd. Because if this fails, then I know that number 1 was odd. But if this succeeds, I know number 1 is even, but if that fails, I know number 2 is odd. Kind of a silly, convoluted example, but I just wanted to show you how this stuff works, and hopefully that helps. All right, you notice that when I did this, I used 2 equal signs. Using 2 equal signs means equality, testing for equality. Using 1 equal sign, 1 means that I'm doing an assigning, like x equal 23. All right, I just showed you the if else, so we really don't have to run through this. Again, I don't always like the way that the authors do this, so I'm kind of writing it my own way here. Again, I also showed you how to combine these things, and I talked to you about the difference between using an and using an or. I mentioned what short circuit evaluation was to you. You see the ands there. All right. I showed you the conditional or, and again, that they're both short circuited. Okay. You can use and or together. In fact, the logical operators themselves, and you saw all these now, but these are them, and, or, and not. For not, oops, sorry. So and, you already saw this, that and was 2 ampersands. You already saw this, that or was 2 pipe signs. And not, our inverter, is an exclamation point. All right, so those 3 things together are the relational operators. But I want to put down here not, and, or. Why did I put that in there? Because that's the order. So if I've got a complex expression that has nots in it, and ands in it, and ors in it, I do all the nots first, then I do the ands, then I do the ors. If I want to circumvent that, I can always use parentheses. All right? And that's pretty much what they're talking about in here. So here is, notice there is an or and there is an and. You can write very, very complex statements. All right? All right, there's also something that's called a switch statement. And again, as always, I think at least, all right, it's much easier. All right, it is much easier. So here we've got this. All right. And they're rewriting this if statement as what's called a switch statement. All right. So let's go in and take a look at what that is, how it's used, etc. And I got to figure out a way to do this in here. So let's see. So I'm going to take this, all this code that I put in here, which, you know, did all this stuff for us, and I'm going to comment it out. All right. All right. So it gives me these green squigglies to say, hey, you got a variable called answer that you're not using. All right. So I'm going to just, right up above this, I'm going to do a switch on, let's say, on num1. No, we're going to do a switch on num2. All right. And we're going to say here, case 0. So if num2 is 0, all right, we're going to put in here, we're going to grab this, and we're going to say break, and default, which means as long as it's not 0, okay, then I want to actually do this. So answer equals num1 divided by num2, and we'll put this in here. And break. All right. So let's run this first. Okay. Let's run this and see what it looks like. So now I'm going to come in here, I'm going to put in 47 and 13 and click this. And it says 47 divided by 13 is 1. Well, that isn't right. Something's goofed up there, and I don't know what it is, but I don't care right now. But I'm going to clear, and I'm going to put in 47, and I'm going to put in here 0 and click calculate. It says number 2 is 0. Division by 0 is not allowed. All right. Now, I could have come in here and rewritten this. So this thing that I put in here as a switch, I could also come in here and write it as if num2 equal 0. If that's the case, then what do I want to do? I want to do this. So here's a switch statement, and here's an if statement that do the exact same thing. How do I know that they're really doing the exact same thing? I'm going to take this and I'm going to comment all of this out that I just put in with a switch. So it's back now with an if, and I'm going to save this and run the program. And again, 47, 13, it's giving me 1. I don't know why, but it is. That's okay. All right, but 47 and 0, number 2 is 0. Division by 0 is not allowed. So it's the exact same way of writing it. So what I want you to see is, for lack of better words, let me uncomment this. So the code here in blue and the code here in blue work the same way. When you have a switch, it's the keyword switch, and then in parentheses, whatever you're switching on, then inside of curly braces, all the different possibilities. We only have two. Either number 2 is 0 or it's not 0. All right, so this could be a lot more complex than it is, but the idea was I wanted to show you this in a very simple context so you can see how it works. So, when you work with the switch statement, it tests a single variable, that was our num2, against a series of matches. We use switch, which began it. Each time we were checking something, we had a case. When we wanted to jump out of the case, we used break, and we put a default on the end, which is always optional, but that handled everything but it being 0 for us. Prior to C# 7.0, whatever you put in the switch, like we used num2, had to be numeric. But now it doesn't. Okay? You can have it be a string or something else if you want to. So if I wanted to do a switch on salutation, and if I put in case Mr., I could say hello sir. If I put case Mrs., I could say hello ma'am. If I put in case Miss, I could say hello young lady. If I put in case Ms., I could say hello. Something like that. And if you didn't put a salutation in, I could just say hello. You need the break, because if you don't put the break in there, it gets, if you don't put a break in there like this, in this example, if we didn't put the break here, and let's say that the year was 1, it would say freshman and sophomore and junior and senior and invalid year. It would keep looking for a break to get out. All right, so you don't want to do that. All right. You can also use what are called enumerations. What an enumeration is you're creating your own data type. Okay? So if you notice here, we've got a new data type called major. We've got 5 different majors. Accounting, which has got a value of 1. CIS, which has got a value of 2. English with a value of 3. Math with a value of 4. Marketing with a value of 5. Well, it might be easier to read this than to have this say case 1, case 2, case 3, case 4, etc. So you use enumerations to make your code more English-like. All right? All right, let's look at this conditional operator here. And again, I'm going to go back to my examples that I've got over here. And I'm making this stuff up, so this has no meaning. But I'm going to say here, int num1 equals 37. Int num2 equals 31. Int max. And I want max to be the biggest number of those two numbers. So I say here, if num1 is greater than or equal to num2, then max is equal to num1. Otherwise, or else, max is equal to num2. It's very straightforward. The problem, if you'd call it that, is we have 1, 2, 3, 4, 5, 6, 7, 8 lines of code to do what's really a very simple test. It's not that it's wrong. It's not wrong at all. But there's a way we can do it which will actually work a lot easier for us, because we can do all this with 1 line of code. We can say here, max equals num1 greater than or equal to num2, question mark, num1, colon, num2. So this 1 line of code, 1 line, called the conditional operator or the question mark colon operator, does what these 8 lines of code do. And let's see how it actually works. It says, okay, compare num1 with num2. This line right here is literally saying exactly what this is. So this means if number 1 is greater than number 2, do what comes after the question mark. So this is the true action, which means take num1 and assign it to max. This is the false action, which says take num2 and assign it to max. So it's a shortcut. You don't have to use it, But if I have my choice between writing 1 line of code or writing 8 lines of code, I'll take the 1. It's easier to test. It's less code to have to maintain. All right, and they give you their own example here, which may be better than mine. Well, you know, this is basically, is your test score greater than or equal to 60? If it is, you write pass. If it's not, you write fail. Pretty self-evident. The not I already mentioned to you. Not married is equal to single. Not single is equal to married. Not union member means that you're not a union member. All right, union member means you are a union member. So it negates. It makes true things false and false things true. All right, common errors. Remember that if you're using assignment, age equal 21, it's a single equal sign. If I want to check to see if the age is 21, then it's if age equal 21. Never put a semicolon in at the end of an if statement. All right? If you've got multiple lines, always use curly braces. I would just say use curly braces all the time. All right? And you can screw up by having something on the left-hand side of a double ampersand or a double pipe sign and nothing on the right. All right? Range checks. If I want to check to see if something falls within range, all right, so in other words, let's assume that if you're a child, your age, if you're a child, we're going to assume here a child is between 1 and 12, okay? So if age is greater than or equal to 1 and age is less than or equal to 12, you know, let's say that it's for the movies, child rate. And let's say if you're less than 1, it's free. Okay? But now let's say that you only have 2 rates. You've got a child rate and a non-child rate, as an example. All right? Or let's say this. What if we did this? If age greater than or equal to 1, and what if we said or here? Or age less than or equal to 12. Well, this is going to grab everybody who's 1 to a zillion. This is going to have everybody from 12 to negative a zillion. That would be everybody. So if you want to do an inclusive check, you use an and. If you want to do an exclusive check, so if I wanted to say if age is less than 1, or age is, let's say that if your age is greater than 80. So if it's less than 1 or greater than 80, we're going to call that free. So if you want to see if things are inclusive, if you want to see if things are included, all right, an inclusive type of range, you use and. If you want to see exclusive, you use or. All right, that's probably more than what the author gives you in here anyway. All right. Use the negation operator correctly. All right. Decision-making issues with GUI programs. Making a decision within a method is no different than for a GUI is no different than a console. You use if else, switch, etc. You can use them in both. All right. GUI programs typically use like buttons or some kind of a GUI control to work with a decision where you don't have that otherwise. All right. So here's an example. It's not that different from the one I showed you. All right. So here it would be GUI-wise, and here you'd have to put it in code-wise. All right. So finishing up, we talked quickly about a flow chart. I showed you what one looked like. We covered the if statement. And when you have an if, what is in the parentheses there is a Boolean expression. The computer only understands true and false, zeros and ones. All right. If you've got several decisions to make, you can use an if-else statement. We looked at the double ampersand for the and, the double pipe sign for the or. We noticed that and takes precedence over or, but not takes precedence over everything unless you use parentheses. We looked at the switch. We went back and looked a little more at the negation operator, and we talked about errors that you can make. All right, so as always, I'm going to come in here. I'm going to grab this, copy that to the clipboard. Let's save this. I can now come in and close this, which will give me Chapter 5. So I can come back in here and add that. And this is Chapter 5, which I think is just called looping. All right, let's double check. Yep, Chapter 5 looping. All right, so I'm done with Chapter 4, and I'm going to go into Chapter 5 momentarily.